Hello friends, let us now learn some important points about the power storage generators. So, power storage generators. Normally we have learned most of the things about X-ray generators, but one thing that we have to see is that there are some mobile X-ray generator units. Especially we see in our hospitals there will be bedside X-rays which happen, right? So that bedside X-rays are done with the help of this mobile radiographic equipment. This mobile radiographic equipment can be taken to the patient room. So when we take normal X-ray equipment to the patient room, the power supply will not be sufficient. So as a result, we have developed power storage generators which supply the power to the X-ray tube independent of the external power supply. Without any external power supply, power storage generator can supply power to the X-ray tube. So this can be done with two types of power storage generators. One, we have capacitor discharge generators. Second, we have battery powered generators. Let us learn about each of them in detail. So first we have capacitor discharge generator. In capacitor discharge generator, this capacitor discharge generator is an electrical device which will store charge or electrons. This capacitor discharge generator can either store the charge or electrons. So what happens is there is an auto transformer. To the auto transformer, a standard 110 or 120 volts power is fed with the help of auto transformer into the step up transformer. Now this step up transformer is a high voltage transformer. So the output of this, 110 or 220 volts of power with the help from auto transformer, it is given as input to the step up transformer. So from step up transformer, the current flows to the rectifiers, right? So the high voltage output is given to the rectifiers, and this rectifiers will rectify the voltage and the current is rectified. Okay. Now this rectified voltage is given to the capacitor. Now the capacitor is charged. So when once the capacitor is charged, so this rectified voltage is used to charge the capacitors. Now when the capacitor is charged, it is discharged to the X-ray tube. So this type of unit uses a grid controlled X-ray tube to either start or stop the X-ray exposure. That means in grid controlled X-ray tube there will be a switch which allows the tube to either turn on or turn off. So what happens is that there is an auto transformer, the voltage or current is given to the step up transformer. So from step up transformer the voltage goes to the rectifier. These rectifiers will rectify the current, and this rectified current or rectified voltage will is useful to charge the capacitors. These capacitors get charged. So whenever the X-ray tube or grid controlled X-ray tube is switched on or switched off, these capacitors gives the charge and the X-ray will get exposed. So the kilovoltage or voltage across the X-ray tube is controlled by the voltage across the capacitors. Now the voltage across these capacitors is controlled by the voltage from high voltage transformer. The voltage from high voltage transformer can be changed with the help of auto transformer, because in auto transformer, if you remember the previous class, in the auto transformer there are many selectors which will help in selection of the appropriate amount of voltage which is required to charge the X-ray tube. Okay, so the capacitor discharge units. This capacitor discharge units will provide very high milliamperes of it. It will provide as high as 500 milliamperes with very short exposure. Okay, what are the uses of this capacitor discharge generator? The main use is they are very small, and thus it is very easy to move them from one place to another place. Then each exposure starts with same kVp, because this is from capacitor, so it will start with same kVp. There will be same kVp, and capacitor is always charged to that same potential only. So that is the capacitor will be charged to that same potential only. That is the advantage. What about the disadvantages? The main disadvantage is that, see, what happens is when the exposure begins, the capacitor begins to discharge. So kilovolts kilovolts are given to the X-ray tube. So kilovolts drops will fall during the exposure. So there will be 1 kilovoltage is dropped per 1 milliampere second supplied to the X-ray tube. So when you supply 1 milliampere second to the X-ray tube, there will be 1 kilovolt drop in the voltage of the capacitor. So if you have to expose 30 milliamperes and the capacitor has a charge of 90 kilovolts, so with just one exposure, almost, see, 1 kilovolt will be decreased for 1 milliampere, so 30 kilovolts will be decreased for 30 milliamperes. So out of it, only 60 kilovolts will remain in the capacitor after the end, by the end of exposure. So that means this type of capacitor cannot be used for thicker body parts such as abdomen, right? Second, the capacitor must be charged immediately prior to use. So this capacitor discharge is not like mobile unit. So what happens is, once you charge it, and then you should use it immediately. If you charge in your X-ray department, and if you have to take it to some other place to use this capacitor discharge generator charged X-rays, during that time the charge will leak from the capacitor. So for example, if you have to go from radiology department to pediatric department, so by the time the capacitor discharge, this capacitor travels, during that time the charge will leak away from the capacitor, and we cannot use this capacitor. So the main important thing is that the capacitor should be recharged immediately, and once after immediate recharge, we'll have to use it immediately. That means the capacitor should be charged immediately prior to use. We cannot take it from one place to another place and then use it. Like we cannot charge the capacitor in one place and transport it to the other place, and we cannot use it to the other place, because by the time the capacitor is transported, the charge from the capacitor starts to leak and charge becomes zero, and the X-ray will not work. The exposure of X-rays cannot be made. Then the second type of generator is called as battery powered generator. So battery powered generators. In battery powered generators, so there is a standard power supply. This standard power supply is used to charge large capacity nickel cadmium batteries. So in battery power generator, the power supply, standard power supply, is used to charge the large capacity nickel cadmium batteries. So these nickel cadmium batteries will operate independent to the connection of outside power supply, because once the battery are charged, obviously they operate independent of the power supply, right? The batteries which we use in our house. So okay, so these batteries are now taken to the department wherever you have to take the X-rays, and these batteries, from the direct current from the batteries, we can see the batteries will give direct current. Direct current is current like this, right? This direct current cannot be used in X-ray tube, right? In X-ray tube we need alternating current, not the direct current, because X-ray tube does not work with direct current. So as a result, this direct current should be changed to alternate current, right? So for this we have to use a DC chopper. So output from the batteries is fed into a DC chopper. This DC chopper will interrupt the current many times each second. Each second it interrupts. So this DC chopper interrupts the current around 500 times per second. So that means it produces 500 hertz pulsed DC current. So that means this straight DC current is interrupted, and thus we will get like this. It's almost similar to alternating current, right? Generally in alternating current there will be increase to decrease like this. But still, this is the rectified current. Rectified current you will see like this, right? But here you can see a peak coming down. Like it's almost similar. So this DC chopper will convert direct current and chop it in such a way that it chops 500 times in 1 second, and thus it produces 500 hertz pulsed DC current. This 500 hertz pulsed DC current is supplied to the primary winding of high voltage transformer. So from high voltage transformer, this is again rectified in the rectification circuit, and this is supplied to the X-ray tube. This X-ray tube will now have 1000 pulse per waveform because it is 500 hertz pulsed DC. So once it goes to high voltage transformer and then to rectified circuit, this will produce double it. So around 1000 pulse per second waveform is produced in the X-ray tube. Theoretically, this will have a ripple of 100% because obviously there is increased decreased. So as a result, this will have a ripple factor of around 100%. So why ripple factor 100%? We can use 3 pulse generator, all of that, right? But we cannot use 3 pulse generators, right? Because the current is from batteries here. So there is no 3 phases, there is only 1 phase, single phase, right? So the battery power circuit will have single phase and there will be 100% ripple factor. Okay. Even if we have to decrease the ripple factorness, one main problem is that if we have to decrease the amount of ripple factor, these batteries, we can add some extra circuits to decrease the ripple factor, but still that will make the equipment more heavier, so it's difficult to carry from one place to another place. So as a result, this is better to use in this way. So the battery powered portable unit is heavy and requires regular battery maintenance. This can be recharged full from any convenient power supply, and for full charging it requires around 12 hours. What are the advantages of this battery powered generators? These battery powered generators can store considerable energy to generate X-rays. So as a result, we can take this battery powered generator from one place to another place, and as a result we can use them repeatedly. Second, they can make exposures independent of a power supply. So as a result, even in remote areas or in bedside X-rays, we can use this battery powered generators. So a typical unit can store as much as 10,000 milliampere second. Okay, so this is about battery powered generators. So the next and last type of generator is called as medium frequency generators. This medium frequency generators is a new type of generator which uses principle of high frequency current to produce almost constant potential voltage. So the main problem with the previous one is that we are not getting constant potential voltage, right? We have a chopped DC with 1000 pulse waveforms are produced. So because it produces 1000 pulse waveforms, the ripple factor is almost 100%. So that means it's not inefficient, it's not efficient, right? So because of that, to prevent that inefficiency, we started using medium frequency generators. These medium frequency generators have the principle of high frequency current. They produce they use high frequency current to produce constant potential voltage to the X-ray tube, and the size of the transformer is also small. So medium frequency generators are also small in size. So in this transformer, the basic principle is based on the Faraday's law. According to the Faraday's law, induced voltage is directly proportional to the rate of change of magnetic flux. So induced voltage is inversely proportional to the rate of change of magnetic flux, meaning that we have a transformer, right? Primary circuit and secondary circuit. Whenever the electricity flows through the primary circuit, this results in increased magnetic field. This change in magnetic field induces voltage or induces current in the secondary circuit. So as a result, this is similar, right? The induced voltage or induced current is directly proportional to the rate of flow change of magnetic flux. So that means for the transformers, we can write the same law as induced voltage in the secondary coil is directly proportional to the rate of change of current in the primary coil. True, right? As there is change of current in the primary coil, that will cause induction of voltage in the secondary coil. This is perfectly true. So what is happening in this medium frequency generator? So in medium frequency generators, the power supply is 60 Hertz current is supplied, and this is first rectified. The current is first rectified. Once the 60 Hertz current is rectified, it will produce 120 pulse DC. Because this is from the power supply, this is alternating current, so this will produce 120 pulse DC. So this is the alternating current. This produces 120 pulse DC. So this 120 pulse DC is now given to the filter. If it is given to the filter, this 120 pulse is smoothened. Okay, there is smoothening of this 120 pulse, and now this smoothened 120 pulse is now given to the chopper. Okay, now this chopper will convert smoothened 120 pulse to pulsed DC. So it has produced pulse DC of around 6500 pulsed DC. Now this 6500 pulsed DC is applied to the primary of a step up transformer or high voltage transformer. So from here, the output of this high voltage or step up transformer will be 6500 hertz high voltage alternating current, because it is pulsed, so now it produces alternating current. Okay, now this is again sent to one more rectifier. This rectifier will produce 13,000. So because it is a rectifier, it will be doubled, right? This hertz will be doubled. So as a result, it produces 13,000 hertz pulsed DC. High voltage 13,000 hertz pulsed DC is produced. So this 13,000 hertz pulsed DC is fed to the one more high voltage filter. Okay, these filters will smoothen this DC, and they will produce they will send this voltage to the X-ray tube. So this will provide the X-ray tube voltage, which is almost ripple free. Okay, so this is one important thing. So the use of this medium phase filters is that it supplies almost constant and nearly ripple free voltage. Then there is no special power supply or voltage required in this generator, and this generator is very small size generators. So okay, this is the important thing. Next, so what does this medium frequency generator does? What did this do, and what is this connection with this Faraday's law? See, what is Faraday's law? The changed one. The Faraday's law states that voltage induced in secondary coil is directly proportional to the rate of change of current in the primary coil. That means as you increase the current in the primary coil, the voltage will be increased. So with the help of this medium frequency generator, what we did is a 60 hertz power supply is changed to 13,000 hertz DC power supply, right? Or else if you start from here, a 60 hertz power supply is converted to 6500 hertz pulsed DC before it goes into the high voltage transformer. So 60 hertz power supply is converted to 6500 hertz pulsed DC before it goes into the primary coil of high voltage transformer. So this is the main advantage. That means it is using the application of Faraday's law, where increase in current in the primary circuit increases the voltage in the secondary circuit. So instead of supplying 60 hertz power supply, we are supplying 6500 hertz pulsed DC to the high voltage transformer. So this is about the medium frequency generators. Then one more important thing is that, remember, output of the medium frequency generator is mainly determined by rate of change of flux. This rate of change of flux is directly proportional to the frequency. It is directly proportional to the number of windings in the secondary coil, and it is also directly proportional to the cross sectional voltage of the core. So voltage is almost approximately equal to frequency multiplied by number of windings in the secondary coil multiplied by cross sectional area of core. So voltage is equal to FNA. So based on this, what can we deduce? So for any given transformer, constant voltage can be maintained by increasing the frequency, and decreasing the number of turns and decreasing the cross sectional area. So if voltage is V, okay, and F is F and N is number of windings are N and area is A. Now what we want is, we want this voltage to be stable, constant. It will be V only. How can we do that? We can either increase the frequency, and if we increase the frequency we will have to decrease this number of turns and also area. So if we decrease the number of turns and area, and if we increase the frequency, this will increase the voltage or rate of change of flux. So what is the result of this? So we have seen in a mobile X-ray units, we need the size of the generator to be as small as possible so that it can be moved very easily. So how can we do that? The cross sectional area of the core can be reduced, that is the iron core, and the amount of wire which is used in the core can be reduced, and number of windings in secondary coil are also reduced. But for maintaining the constant voltage we have to increase the frequency. So that means, what is this medium frequency generator is doing? The medium frequency generator is increasing the frequency from 60 Hz to 6500 Hz. So with the help of a medium frequency generator, we can, so with the help of this medium frequency generators, what are we doing? We are increasing the frequencies. So we are increasing the frequency from 60 Hz to 6500 Hz. So in this way we can decrease the number of windings, and we can also decrease the cross sectional area of the core area. So by decreasing these both, what are we doing? We are making it smaller. So these medium frequency generators will provide a nearly constant voltage to the X-ray tube, and it is independent of power supply. And this occurs at high frequency. It produces efficient transformer, and it also makes it smaller. The circuit itself will become smaller. Okay, so with the help of this medium frequency generators, the size could be reduced to almost 1/3 the size of the transformer. So for mobile circuit, using these generators will make the circuit smaller, and if cross sectional area and number of windings are decreased and frequency is increased, this will result in constant voltage. So these are the important points about the generators. Thank you.